Hello, everyone, and welcome to this latest webinar from OMDIA brought to you by Informatech. Today's topic is PON innovation for now and the future. We will be discussing innovative approaches to bringing PON into the Metro network. Our webinar is co-presented by OMDIA and our partner, Juniper Networks. My name is Julie Kunstler, and I'm Chief Analyst at OMDIA, focusing on broadband access infrastructure. I want to thank everyone for joining us. Today, we are joined by Anisha and Anil Damani, Product Manager with Juniper Networks, and Robert Damon, Senior Consulting Sales Engineer with Juniper Networks. Welcome. We are honored to have you with us today. Now let's get things started with the presentation. And we're going to begin with market trends, and I want to spend a few minutes highlighting some market trends in the PON equipment market. The first is looking at measuring PON success. PON is the fiber access technology of choice. We've seen very strong growth in the PON equipment market. There's been deployments by a wide range of operator types, including integrated, fixed only, and even mobile only. We've seen this in all regions. China is no longer dominating consumption of the global market, as numerous operators in Europe, the Middle East, Asia Pacific, North America, South America, and Africa are building fiber access networks using PON. In addition, there is very strong movement to next-gen PON, and in some regions, next-gen PON has begun to dominate networks. Next-gen PON is supporting traffic growth from residential, enterprises, and xHaul transport. Vendors are entering the ecosystem with innovative approaches, bringing access to existing solutions and strengths, such as adding access to switching and routing, and adding PON features and functions into the BNG platforms. PON has been evolving from what was considered a best efforts technology for fiber to the home and fiber to the building to being able to handle very different types of traffic in different types of applications. It is the underlying technology for what we're calling the unified fiber access networks, trying to take advantage of that optical distribution network build and using it for many different types of applications. While not all traffic will be put onto a PON network, the underlying ODN can support different types of customers and requirements. The rapid adoption of 10G, and specifically XGS-PON, 10G symmetrical GPON, and the use of PON for residential and non-residential is attracting new approaches to PON technology and new vendors, which brings us to Juniper Networks. Over to you, Anisha, who will talk about the problems and challenges in the PON system.
Thank you, Julie. So as Julie mentioned, vendors are entering the PON space, and next generation PON is dominating different use cases. The important question is, why are they doing it? With the increase of work from home, homeschooling due to COVID, the demand for high-speed services has increased, which essentially means that the traffic in metro space is growing fast. In situations like this, the operators are looking for a solution that provide increased speeds, easy to scale options, and efficient paths to access the services. Let us explore the options available for last mile technology. Option 1 is Ethernet to home, which is a little complex to deploy. Option 2, DSL, but operators are looking for a little bit of more faster solution. 3 is cable technology, but the requirement is very different from a cable technology. 5G, which is work in progress, right? So essentially, I understand the requirement is a nice niche of Ethernet to home and cable options. From an operator's point of view, there is also an increased competition that you see. You see Elon Musk satellite offering, Google Fiber entering the space, and of course 5G trying to solve this problem. However, I think PON fits the bill much better. PON is simpler to deploy, You just need a few splitters, and you can now deploy 10 gig PON, which provides loads of bandwidth. Even before we go into more details of the options, which will be covered by Robert, let's take a look at a typical PON deployment. A typical PON deployment has a bunch of ONUs at the access layer connected to a dedicated OLT shelf, which in turn is connected to an aggregation platform and then to a subscriber access. But there are some challenges here. In case of a greenfield, you are essentially looking for an economical, simple, and fast time to market. And in case of a brownfield, you want to upgrade from 10 gig to 10 gig from existing GPON, EPON networks, that is 1 gig or 2.5 gig. You're looking to do an upgrade from 1 gig or 2.5 gig to 10 gig. In this scenario, what you will have to do is you'll have to upgrade your transport connections, ONTs or access switches, and your OLT shelves. You must also scale your OLT uplink from 10 gig to 100 gig. You must take into consideration the power and space calculation and also deal with vendor lock emissions. In a nutshell, in case of a brownfield deployment, you must consider an entire end-to-end ecosystem while upgrading. Good news is there is an innovative approach available to avoid all the hassle. Robert will walk us through it in detail. Robert, over to you.
Thank you, Anisha. The latest innovation in PON has been the collapsing of the optical line terminal, or the OLT, into a small form factor pluggable optic. This is allowing for the installation in router ports, making a PON network a direct part of the access layer. By leveraging advanced silicon processes, a complete system on chip containing the intelligence to bridge XGS or 10 gig EPON directly to Ethernet is contained in an SFP plus optic. This evolutionary design distributes the OLT functionality, reducing failure impacts and creating a port-based scalable model. This also serves as a form factor to allow for future growth as 25 gig PON and 50 gig PON become standard and developed in the future, using the same pluggable form factor. The result is the elimination of the specialized PON shelf, the optics, and the fiber interconnects to the access router. Now, instead of a single-purpose chassis full of line cards, this allows PON services to be delivered the same way as direct internet access, mobile backhaul, or WAN services. A single access device can be used for residential, commercial, and enterprise applications, no longer limiting PON to just residential broadband. Julie, I believe you have a question for the audience regarding this.
Yes, I do. So we have one poll question here, which is, are you using or are you considering the use of PON infrastructure for non-residential customers or applications? So we'd really appreciate your answer to this poll question, and we'll have the answers in just a couple of seconds here. Wow, so this is great news, at least in my opinion, as an analyst, that we are seeing that everyone in the audience is either using PON for non-residential or at least considering it. So Robert, back to you.
Thank you, Julie. Yeah, interesting response on that. And remind the audience, if you do have questions, please submit them. And yes, looking at that as far as being able to do non-residential applications, having a modular design really will play into be able to put PON in places that you haven't before. When we compare this modular OLT to traditional PON deployments, we see several advantages. By creating this open environment, the all-or-nothing model with a single vendor or technology is eliminated. This gives you the ability to rapidly build a best-of-breed design with the right ONU deployment for the right service.
So can I stop you for 1 second here, and can you expand a little bit regarding easing into PON? This seems important, especially for network operators that have previously focused on active Ethernet.
Sure, Julie. And this modular design allows for an easier deployment of PON to the network by simply just adding a SFP OLT to an existing router port. Services can be quickly deployed as market demands arise. Even if there are current slower speed PON deployments, the modular OLT allows for 10 gig PON to be added without network-wide upgrades. As a result, you'll be able to quickly deploy PON equipment, avoid or eliminate specialized hardware, saving precious space or power, and deploy more services no matter what the last mile technology is used. When you compare 10 gig PON to 1 gig active Ethernet, you can immediately see the benefits in saved ports. Having a design that allows you to deploy PON alongside of the active Ethernet deployment on the same platform also gives the operator even greater flexibility.
So can we focus for a moment on power, because there's tremendous focus on carbon neutral. Historically, regulators have really focused on the customer premise side, right? Bringing down or encouraging operators to lower the power consumption of devices in the home, because after all, the regulators are really there to protect the subscriber, the consumer. So I'm interested if you can elaborate a little bit more on how your approach helps to bring down energy usage.
That's a great point, Julie. And, power consumption has become a forefront in network design. Newer devices have greatly reduced the power per gigabit when you eliminate, in the equipment, with the faster speed equipment, with the newer designs. But when you eliminate the additional processors, line cards, and fans of a dedicated OLT shelf, you can see that there's going to be a savings that are going to be able to achieve in the central office or in the remote cabinet. This also gives you the ability to reduce the size of the power plant required, the backup power, the batteries required, as well as the cooling equipment, or at least costly, time-consuming upgrades to those devices when you go to upgrade those. One other thing to note is that with the elimination of the OLT shelf, you no longer need the high-speed uplinks to the access router. This frees up additional ports, increases reliability, and reduces cost in both the optic cost as well as the power required to be able to do that. I want to talk a little bit about how this would work in a deployment model. If we look at the PON architecture in the network, we can see, this is a typical service deployment serving a wide range of customers, both residential and commercial. OLTs are generally deployed in a head-end or central office environment or in a remote cabinet or on a pole. This flexibility allows for the distance to the customer to the OLT to be minimized. One of PON's main advantages is using a single shared fiber design, saving resources as a single OLT port can serve many customers. PON standards can support up to 128 customers on a single port. But Julie, I think you're seeing something different in the model of how customers are deploying PON today.
Yes, that's correct. So at one time, PON infrastructure, and here we're really talking about the underlying ODN, was very standardized. In the beginning of PON, in the beginning of EPON and GPON, we were really looking mostly at 1x64 splits, sometimes 1x32 splits. But today, I'm seeing a much wider variety. There's some overbuilders that have even done 128 in an attempt to cover, to really like a land grab, get as much out there, get as much fiber deployed as possible, own that fiber pipe, like a land grab situation. I've also seen much lower split ratios, 1x16, 1x8, and some analysis has shown that even 1x4 can be much more economical than a point-to-point active Ethernet approach. So there's a lot of variety out there, and that's part of why the flexible approaches have become so important, because different operators have very different strategies on what they're trying to achieve, such as coverage versus a much bigger pipe, for example.
Well, thank you, Julie. And, I've kind of seen the same thing in my talks with customers where maybe, even though the PON standards say 1 by 128, really, focusing in on 1 by 32 or smaller, or at least the ability to further break that down as you get customer demands. Like you say, building it out for the land grab model where you do, can deploy it with a 1 by 128, and then be able to scale that down as you start adding customers to the servers. And that's where having this modular OLT is nice, because you're not stranding OLT ports out there in advance. You're adding them as the customer demand grows. So that really helps you out with that. And then, since the same device can be used for multiple services, it's easy to add the OLT anywhere. Since 10 gig PON, amplifies the bandwidth fundamentals of PON, places where you've been able to use PON, haven't used PON before because of the lower bandwidth, it really gives you the ability to use that. And you brought up the point about a 1 by 4 split. That really becomes a great alternative to active Ethernet deployments. And it's really also being able to see PON being used in applications that are not residential in the commercial space as well. And this is, we're seeing, places like inside buildings where, maybe riser fiber is a premium, or even in campus environments. It really kind of has those plays. And it's also important to note that, the PON infrastructure that's out there in the physical plant, we're talking about the splitters and the combiners and all those gear. This is the same infrastructure that's used for 1 gig PON. It's the same infrastructure that's used for 10 gig PON and will be used before. These passive devices are the same low-cost devices that we've been used today. So nothing special has to change in the outside plant to make this. But as you were saying, Julie, that reducing the split counts is really some of the models that we're seeing these providers go to. With the modular OT, you can also, the explosion of IoT, private 5G, hospitality, remote learning, as Anisha mentioned, and high-speed Wi-Fi have all driven higher demands in locations where PON has not traditionally been looked at as a feasible choice. But with 10 gig PON, it really becomes a decision point that can be used for deploying your network. As you can see, the applications for PON are far-reaching. The innovation of the modular PON OLT allows for a common IP service fabric to be deployed for all services. So, you can see here there's a whole lot of different types of services that can be offered with PON.
Yeah, so if I can ask a question here, how can an operator manage multiple applications on a single PON network? And I think specifically, how does Juniper's approach support this objective? How does this fit into your existing management system, for example?
Well, sure. Well, that's a great question. One of the things by creating a common IP fabric, and this IP fabric, lives at the heart of, where, things that have been deployed in service provider networks and even in enterprise networks for a while. You can have a streamlined approach for all applications, allowing for simplified engineering as you reduce the complexities of separate networks, multiple devices, a myriad of routing protocols, the ability to move seamless between direct fiber, active Ethernet, or PON, allowing for adaptations. Because now PON is treated just like another access in the network. It's it's an interface in the device. So there's really no difference in how you would treat a directly connected mobile backhaul service versus a PON access side, or versus another side plugged into the router. Because now everything is brought up to the router level, and you're able to apply the QoS, the quality of service models, apply SLA parameters, and be able to deliver these seamlessly and effortlessly, no matter how the network evolves. One of the key requirements in offering PON services is subscriber management. This cloud metro design allows for centralized deployment of the broadband network gateway, or BNG, device, with the flexibility of using technologies like EVPN over MPLS to connect to the customer surfaces. This allows for simple management, IP address application. If you need to add services like network address translation or NAT, and even the law enforcement compliance services that you need to do if you're providing residential services. As you can see, by having this simple cloud metro design, you can create a scalable design as you can keep adding nodes, you can keep increasing speeds from 10 gig to 100 gig to now 400 gig, and be able to deploy high capacity platforms that have both PON and non-PON services. If you look at the cloud metro as a whole and what this means to the networks and how by pulling PON into this really gives it as an innovation, it's the converged network for all use cases. A cloud metro converges all metro use cases, whether it be residential, business, mobile backhaul transport, onto a single converged architecture with a single operational model. Network operators can also apply special treatment to different traffic and service types under different service level agreements, SLAs, over the same infrastructure. By leveraging this, a cloud metro network can intelligently steer traffic to the right physical or virtual resource in the most efficient way to optimize the user experience. It optimizes capacity and utilization with control plane and user plane separation, or CUPS, and modern traffic engineering protocols. Whether it's commercial traffic that gets handed off directly to the internet, subscriber traffic needing services from the BNG, or the deployment of local caching and services, the Cloud Metro provides an intuitive and scalable framework. I think Anisha would like to go through Juniper's approach to how we're handling PON networking.
Hey, thanks, Robert. So the unified PON is supported by Juniper's multi-service A65400 series, which also supports advanced metro use cases. So these are access aggregation platforms that combine 1 gig and 10 gig client services with 100 gig uplinks, including 100 and 200 gig DWDM options for packet optical convergence flexibility. As Robert mentioned, the 10 gig PON OLT in our solution is treated as a standard Ethernet port within the ACX. This greatly simplifies the provisioning required for the solution. The standard Junos features and functionalities are leveraged to provide both the control plane and data plane user paths. At Juniper, we have combined the ACX router with a smart pluggable revolutionary OLT, which comes in an SFP plus form factor. So this eliminates the OLT shelf, helps tackle the power and space constraints, and reduces the solution from a 2-box solution to a 1-box solution. The OLT supports selectability for both 10 gig SGX PON or 10 gig EPON, along with the management platform to control and provision all functions on the PON network. Leveraging the pluggable SFP plus form factor, we create scalable design that allows our ASICs to provide multiple services like mobile backhaul, direct internet access, along with PON services, thus eliminating the need of any specialized services or separate networks. We have integrated the PON controller into Junos, so the operators can take advantage of Junos operating system, Juniper BNG's Paragon automation, and more as they add 10 gig PON offerings to their service portfolios. It also interoperates with third-party PON distribution equipment, thus avoiding all the vendor lock-in issues. We have a microclimate management system, the MCMS. It is a single-page web application which provides graphical user interface for provisioning and managing the PON network. With MCMS, users can define templates for standard service deliveries, easily onboard the OLTs and ONUs, create end-to-end services on the PON networks, manage the ONTs and ONUs in network, including firmware management, and monitor the PON network and collect details of network health and SLA compliance. There is also a netcon server that provides direct provisioning over a standard space interface. Through the MCMS GUI, a user can select an ONU at the endpoint and define a service based on a fully customized template. To summarize, Juniper's unified PON delivers a high-density, standard-based pluggable architecture, combining an integrated and consolidated 10G PON OLT transceiver and a PON management solution with the ACX Universal Metro router. The combination of an open design allows the use of a large ecosystem of third-party ONU vendors, eliminating the access vendor lock-in issues, and the BNG with advanced subscriber management features gives the PON network access and the metro access aggregation routing capabilities for a complete converged access solution. So this is a complete converged access solution that you're looking at. So isn't it exciting? Julie, what are your thoughts on this one?
Yeah, so clearly one of the goals is to try to converge the access network. You know, we've seen it at the services level, right, where we've seen operators, either integrated operators or fixed-only operators who then become MVNOs, you know, virtual mobile operators offer voice services, data services, video services, and by voice, you know, whether you're at home or on the mobile network. What's taken much longer, in my opinion, is the convergence at the access network layer. And this is becoming more and more critical given the growth in traffic and the need for operators to control their costs, both CapEx and OpEx. And this is clearly one of the advantages of the PON technology, is the ability to bring down the cost by reusing that network. You know, the cost of the PON network is really in building out that infrastructure, the construction project, whether it's buried fiber cabling or overhead. So why not reuse that network for as much as possible? You know, and this leads to the conclusion slide that I have, which is that PON, and here we're talking specifically about TDM PON, which is what has been so incredibly successful in terms of acceptance, adoption, deployments, upgrades. You know, it really has evolved, enabling CapEx and OpEx savings and providing flexibility to different kinds of broadband service providers. You know, higher and higher bandwidth. We've seen the movement from, you know, EPON to 10G EPON, from GPON to XGS GPON, more and more around 25G. There have been announcements this year about 25G live networks and a lot of testing going on. And certainly in the future, we expect to see 50G. We've even heard about 100G lab testing. PON itself has really gone beyond best efforts supporting non-residential subscribers and applications and becomes a unifying access technology, and being able to bring access into the metro and taking advantage of a lot of the metro capabilities that the metro network providers, vendors, have given to their customers, the service providers. So it's really a lot of development that we've seen over the last years, and that we're going to continue to see, you know, given the very successful role that the PON technology has played. And now I want to move to Q&A. We've gotten in really a lot of questions. Please keep submitting them. As mentioned, if we don't get to all of them now, we keep them, and Juniper will be happy to answer the ones that we don't get to live. So one of the questions that's come in a good bit is, Juniper has focused on the OLT side. So how do you ensure that there will be enough ONT, ONU vendors for your customers to use with your OLT solution?
Yeah, I'll grab that one,
Anisha. Okay.
Yeah,
okay,
and that's a great question, Julie. And that's one of the things that's been a differentiator is our approach to looking at PON in an open environment. And that really kind of leads to how Juniper's approached routing in general, and most of our products is open standards and creating the market for it. We've already seen several vendors in the market that are producing the ONT, ONU devices out there, ranging from traditional simple ONUs to full function gateways that support features all the way up to like Wi-Fi 6. And by following the standards, that these are easily onboarded onto our system. And we've got a pretty large array of ones that we've already interoperated with, ones that we're in field test with, and ones that we have, that we're working with customers to deploy. We are seeing quite a bit more uptick and demand as far as on the RFP side of XGS PON deployments. We're seeing this as becoming the predominant standard, and this is what we're seeing a lot of the ONU vendors support. Even though they have the capability of doing EPON, we're seeing XGS PON being the leader right now at this time for 10 gig PON deployments. And so it's that coupled with the open system and the onboarding side with the vendors, it really, we're not concerned with not having the far end devices on there in the best of breed approach.
Mm-hmm. Yeah, thank you. So as an analyst in this market segment, let me add a little bit here about PON and what I'm seeing. So in the second quarter of this year, we already saw in North America XGS PON shipments almost match those of GPON. So there's been very rapid adoption of XGS PON OLTs, and here I'm talking on the OLT side. We expect the ONTs are happening, next-gen ONTs, specifically XGS ONTs. But certainly on the network side, we've already seen the movement, very strong adoption of XGS PON. It's simply, there's a couple of reasons why. One is that it's stable. There's numerous vendors supporting it. It's commercialized, and there's been a lot of lab trials done, a lot of live networks deployments done. So there's a lot of confidence that XGS is mature. Second, the prices are coming down. And so if an operator who's trying to decide between GPON and XGS PON for 5 times the downstream and 8 times the upstream, because we have to remember that GPON is 2.5 over 1.25. So for tremendous bandwidth growth, your capabilities, you're not paying 8 times for XGS PON equipment. So many operators that have not yet begun to deploy PON networks, and we're definitely seeing this with the overbuilders and with some of the even incumbents who have been slower to build out the PON networks. Some of them are beginning with only XGS PON. If they're telcos, a few cable operators are doing the same with 10G EPON. But certainly for those that are looking at GPON, we've seen a lot go with XGS. And with the momentum of XGS PON shipments for the network side, whether it's a central office or a head end, if it's a cable, or in a distributed environment, so smaller, let's say, OLT solutions to be distributed out into the field, the momentum is there. The price points have come down significantly, and consequently, we're seeing rapid adoption. Outside of China, it's almost only XGS PON, and that's because the operators really want to see the symmetrical capabilities to support a lot of enterprise services and xHaul transport. So another question that's come in from several different people is if you can talk a little bit more, Juniper, about the unified IP fabric. What does this approach really enable me to do in terms of convergence? You talked about it a little bit during your presentation, but if you can go into more detail, I think it would answer probably 10 of the questions that we've gotten in around that.
That's great. I don't know, Anisha, would you like to?
You can go ahead with that one, Robert.
Okay, not a problem. No, yeah, and you're right. There were several questions on that, and it is great about that is, one of the things that when you look at the way traditional networks have been built out, maybe with some sort of Ethernet ring protection or layer 2 type of side or WDM, the ability of having an IP fabric and taking advantage of what we're seeing with 400 gig lengths now, and the capability of the platforms And then the simplification of protocols, things like segment routing, MPLS over segment routing, being able to use for traffic engineering, to be able not to have reserved bandwidth, and being able to create this IP fabric gives you a model that you can, almost like the shampoo bottle and lather, rinse, and repeat. You can actually create the same model for deploying services across your entire network. The edge device now can actually pick up if you're deploying enterprise services, or if you're deploying mobile backhaul, or if you're doing other types of services at the edge. The common IP fabric makes it easy for you as an operator for training, for management, for deployment, to be able to have one common protocol, one common set on there. And this is really what lends it into having PON go into places where PON hasn't gone before with residential side. Whether it's using for IoT devices where you're using PON to aggregate up from outside locations, whether it's in different buildings, or whether it's for hospitality applications. We're seeing quite a bit in the campus market, looking at for dorm room or even remote building sides. There's quite a bit things that by having this, your configuration of the device at the edge, you don't have to put a special device for business services. You're not putting a specialized device for residential services. You're having a common transport side, and you're elevating your transport to this IP service fabric.
So if I can just add on a question for you, Robert. So Natalie has to worry about there being a traffic jam and at the metro level?
Yeah, and there is. I mean, if you look at where the growth is, one of the things I like to show the chart is of the metro is where the pressure's at. The metro is seeing as you start upgrading the links, the metro is the first place to feel the pressure. It's and by using an IP fabric versus using traditional layer 2 transports, you're eliminating links that are blocked for loop protection and being able to fully use the bandwidth. Also, by enabling protocols like segment routing, you can now take advantage of traffic engineering. You can actually have your low latency, high bandwidth services take the most express path through the fabric, and being able to spread the best effort traffic along other links in the network. This will allow you to take full advantage of your network before you do costly upgrades of adding links or pulling new fiber.
Great, thanks. Another question is around coexistence. So what do you say to an operator who's already deployed either 1 gig EPON or 2.5 gig GPON? How can they work with Juniper's solution here?
And that's a great question, Julie. I mean, we get that quite a bit because, the solution that we have is 10 gig symmetrical PON, whether it be 10 gig EPON or XGS PON. So one of the nice things that they've done in the standards bodies is that these services use different wavelengths on the optical spectrum. So by using what's called a coexistence device that can combine these traditional 1 gig, 2.5 gig PON with 10 gig PON, you can actually run these services over the same fiber. Now, what we've seen is that, with the deployment of our solution is that most people are looking to cap their current 1 gig, 2.5 gig PON investments or their separate OLT shelves. So by using these external coexistence devices, it allows you to seamlessly, add these services on there on the same fiber tree, and as well as being able, once you migrated customers to 10 gig services, to roll them over and remove the coexistence device from the network.
Mm-hmm. So you solve their upgrade problem today efficiently, and then give them room. It sounds like there's an efficient way that you can help them here, if I'm understanding this correctly.
Yes, yes, and by doing this, it allows to be able to pick and choose where you do your upgrades. Lots of times it's easy to say we're going to deploy new markets with the existing technology, but maybe you do have a customer along the network. Maybe it be a business customer or some of your higher end customers that you want to provide a higher speed service to. By using this, you can layer on top of the existing PON network and be able to upgrade select customers on there and leave the ones that you have on there and maintain the investment you have in your legacy GPON network.
Yeah, that's really important, right? So both of you touched on a topic that I think is extremely important, that once you move outside of residential, you get into a lot of questions around reliability, security, SLAs. Typically as residential users, most residential users don't have SLAs and would not be willing to pay for any type of SLA, service level agreement or promise of a fix within a certain amount of time or a payment if that doesn't happen. So I'm interested for you to go into a little bit more detail on how you can ensure SLAs, because this is one of the key from our findings from surveys with service providers. And yes, they may be considering the use of PON beyond residential, but then they raise a lot of questions. And one of them is around, well, can you still give me an SLA? How are you going to monitor that SLA? What's that SLA going to be based on?
I don't know, Anisha, if you want to touch on our active assurance.
Yeah, definitely. So essentially, we have the MCMS system, right? And that it will help us monitor the ONTs and ONUs and get all the network health and ensure that the SLA compliance is in place. Along with that, with the fact that the PON controller is integrated on Junos, we have an entire bigger Paragon automation suite that takes care of the SLA parts, right? So we definitely have product lines in place that are taking care of this SLA demand, right? Like Ask. So it's all there. Like if you look at it from a solution end-to-end point of view, right? So I don't know, Robert, if you have more details that you'd like to share.
Sure. I mean, and Julie, I know you mentioned that residential customers don't want to pay for an SLA type of service. But it's also important to note that with a lot of the recent funding rounds for projects like rural broadband and being able to increase residential services, there are requirements from the FCC and other agencies that you maintain a certain performance and latency. So it is important to monitor those. And as Anisha mentioned, that the ability to do this is in the ability to gather statistics and being able to gather historic statistics and being able to produce those in reports. So it's key, and she touched on the fact that the microclimate management system is gathering these stats, and there's lots of stats that you can gather from both the OLT and the ONUs to be able to ensure that you actually are delivering the customer experience that they're paying for.
Great, thank you. So there's an interesting question here. Our current PON provider is challenged interoperating with MPLS services. As a leader in MPLS, does the Juniper solution allow us to easily deploy MPLS over the integrated PON network?
Sure, and I'll jump onto this. We've cut out the middleman directly by having the PON services on the device. What's kind of nice about that, and what's also nice about Juniper as far as a leader in broadband network gateway services, is that we're able to bring the MPLS direct network all the way up to the PON network, and being able to tunnel subscribers through layer 2 circuits or EVPN across the MPLS network to terminate directly on the BNG. And one of the key features on our BNG platform is the dynamic service creation. So this means you're not manually provisioning subscribers on the BNG. you have the BNG in a listen mode where it's listening for subscribers as they come online and dynamically building the service, authenticating the service, and provisioning the service as they come on there. So, the neat thing about it, and to reiterate, by having the PON OLT as part of the router and part of the Cloud Metro architecture, it's directly integrated with the MPLS network. And you get all the benefits of all the traffic engineering and everything that you do for your other services over MPLS.
Mm-hmm. Great. Thank you.
Yeah, Julie, so just to add on to that one, right? The fact that the PON control is integrated on Junos, Junos has a bunch of services that can be utilized, right? So this entire transition of the packet transfer is going to be pretty seamless, right? It's not going to cause like a lot of problems with respect to an overlay function. So it's very easy. We can definitely do it. The short answer is yes.
Mm-hmm. Yep, that's great to hear that. So another question is, how does the Juniper, or can the Juniper solution support a distributed architecture for remote locations, like deploying PON in a new business park? Interested in, this question came in a couple of different forms, but the point is about distributed architecture.
Sure. I mean, I think, by nature, with the modular OLT, that is a distributed architecture. We are now putting the OLT, all the intelligence of it, on a single SFP+. So instead of a single OLT shelf, you're distributing the OLT functions across the individual plugs. So you're decreasing the blast radius of the failure of a single device. But what this also means is now this OLT can live outside of the traditional network locations. This could live in the basement of a building. This could live in a wiring closet at the end of in a strip mall. So this allows you to push these services further out, and all your OLT ports don't need to be in a single location. And that's what the flexibility of this modular design brings to you. And by being able to connect them all together with the IP service fabric and being able to deploy those in devices that are either in conditioned spaces or out in hardened locations, this gives you the flexibility to provide those services and get into those markets. Anisha, do you?
Mm-hmm.
Yes, definitely. Nothing more to add on to that one.
Great, thanks. So there's a couple of questions here that I would like to take, and it's around the next generations of PON and what do I see happening. So one of them is, what's my take on NG-PON2? So NG-PON2 has only been deployed by a very few operators. And what it comes down to is the cost of tunable lasers. They're just expensive. So from an architectural viewpoint, NG-PON2 reminds me a lot of WDM-PON, which is that it's great on paper and it looks like it has many advantages on paper. The problem is the cost. And because NG-PON2 has not been widely deployed, it does not have any volume behind it, which means that the cost, there's just not enough pressure to bring down the cost of those tunable optics. So I don't expect to see it widely deployed. I don't expect to see it gaining significant momentum. And you can see that in the OMDIA equipment forecast, that yes, there will be some deployed every single year, but it's just not in volume compared to XGS PON. So what about 25G PON versus 50G PON? And I hate the use of the word versus here, because to me it's both. So we've begun to see some 25G PON. It's not standardized by the ITUT. It has been standardized by the IEEE. MSA was formed around 25G PON, and as I mentioned earlier, we began to see some deployments this year, and we expect more. It's not for, in my opinion, we will, 25G PON fills a need, and the need comes from two places. It comes from service providers who want to be able to offer 10 gig services, even up to 15 gig services to enterprises. So there are a number of broadband service providers who have gone aggressively to enterprises and to bring those enterprises onto the PON network with high bandwidth services. Not every enterprise, of course, needs 10 gig or 15 gig or beyond, but with 25 gig selectively used, they can offer those higher bandwidth services. The second place where we've seen interest in 25 gig is around different types of what I call XHaul transport, such as wireless backhaul. And again, it depends on the topology of the 5G small cell network, or what the operator expects that topology to look like, and whether they need 25 gig or not. Then there's other operators who say, we don't need 25 gig, we're going to wait until 50 gig becomes available. And in many of those cases, those operators do not have plans to use PON for transport. And so, sort of coming up a few layers in my analysis here, PON has been so successful as an access technology that we're now seeing some diversity, and in my opinion, the PON ecosystem can handle it. And what do I mean by diversity? Really diversity in applications and types of subscribers. If we go back to one of my early slides, PON was a best efforts FTTH and fiber to the building technology 15 years ago. As it's been widely accepted and very widely deployed, operators are now using it for different strategies depending upon how much fiber they have in their access network, how much competition they're facing from other operators or from overbuilders, wholesalers, for example, and what types of subscribers they want to go after or have. So there's a lot of different strategies now forming around the access network and how best to make more money on that optical distribution network. So we're seeing more diversity, and the good news is that the ecosystem is at the point where it can handle it well. So this is a question, another question around SLAs. So regarding PON SLA monitoring and end-to-end service KPI monitoring, would you recommend use of Y.1731 in general, and specifically for a network of around 300,000 subscribers? So I know that this is a very specific question. I don't know, Robert or Anisha, if you want to take that one.
Sure, Anisha. I don't know if
my
you wanted
answer.
to.
Yeah, Robert, I will take that. You can add on after me. I think my question, my answer is just gonna be like, it really depends, right? 300K subscribers, yes, but then what are the other things that you're trying to do? How is the deployment gonna look at? So, not a really straightforward answer, but it just depends. I don't know, Robert, you have more?
Well, yeah. So I mean, I guess there's a couple of things that you want to look at. As far as your subscriber services, I mean, obviously the health of your network going to the OLT or going to the access device is key, and we are seeing a move from using things like BFD or other protocols to using the 1731 type of monitoring device to get better OAM data out of the links in your network. That's one place for that to be used. As far as monitoring your subscriber health, like we mentioned, there's a lot of statistics you have, and there's also the rate of how much statistics you gather and how much you can produce with that. One of the things that we've looked at is that it's really coming into the key of what's looking at with current network deployments and where people are moving their network deployments to, and it's in automation and looking at how you can gather this data and how can you have processes looking at this to develop. Not only is this, getting some sort of alarm or getting some sort of data going, is this something I need to be worried about? And that's one of the techs that we've been taking with some of our applications in our Paragon automation suite, is to develop what is a baseline so that you do know what is an anomaly, but what is just regular standard values. And that's key, because what may be happening in one part of the network is different than what happens in the other. So again, I think going back to your question about using Y1731, I think that's important to incorporate into your network, to look at your link health, look at your connections on that side, and being able to gather additional data that you would probably not traditionally have with other OAM protocols.
Great, thank you. So one quick question, which I'll take, which came in after my discussion of the next generations of PON, is, can these coexist? And yes, they can coexist. This is something that the PON ecosystem made sure of, is that there is coexistence. So you do not have to rip out anything that you've put in, and you can decide where and when to upgrade, both on the network side and on the subscriber side. And this is really important, because what this means is that you can do network side upgrades before upgrading a subscriber, and then only upgrading to be upgraded or is willing to pay for a higher level, a higher speed service. So we're almost out of time. So
real quick, Julie, I would like to interject something right there.
Oh, sure. Sure.
One thing to notice, you're mentioning on that, is the platforms that are being developed at this time. Those SFP ports a lot of them now are capable of both SFP 10 gig, 25 gig, and 50 gig. So with this modular device, it's going to mean that these will be able to live side by side in the same device as well. So just wanted to add that note there.
Yeah, thank you. Yeah, that's important. Thank you. Great. So I'd like to thank everyone for joining us today and for submitting your questions and comments. I know we did not get to all of the questions, but as I said, we do have these and we'll be able to follow up. An archived version of this webinar will be available shortly, so feel free to come back and view it and share it with your colleagues. A short survey will appear at the conclusion of this webinar, so please take a few minutes to fill out that form. Please make sure that you follow us on Twitter and LinkedIn for information on future webinars from OMDIA. Again, thank you for joining us, and we wish you a great rest of the day or a great evening, depending on where you're calling in from. Thank you so much.